This is Module 1, Lesson 2, Algebraic Expressions. After this lesson, you need to be able to write algebraic expressions for verbal expressions, and you need to be able to evaluate algebraic expressions. Let's learn writing algebraic expressions. Here are a few vocab words that you're going to see and we're going to reference throughout this lesson and future lessons. First, a variable is a letter that's used to represent an unspecified number or value. So we don't know what the value is worth. An algebraic expression is an expression that contains at least one variable. A term of an expression is either a number, a variable, or the product or quotient of numbers and variables. So you would see those as like 3x, that's the product of a number and a variable, or maybe, x over 4. There would be a quotient. A variable term is a term that contains a variable. So 3x would be a variable term, or just a, or b, or x. And then a constant term is a term that does not contain a variable, like 5. Example 1. Write a verbal expression. There are a few common verbal phrases associated with operations. These phrases can be used to interpret an algebraic expression. So here are a few. For addition, we might see more than. Please be careful on this one. If it says is more than, with the word is in there, that would mean greater than. But here, just more than means addition. Sum, plus, increased by, added to. Usually, I'm going to write this one on here too. Usually, if you see the word and, 95% of the time it means addition. Subtraction. Just like addition, be careful with the less than. If it says is less than. Subtracted from, difference, decreased by, or minus are all common ones. Multiplication, product of, multiplied by, times. And then division, either quotient of or divided by. So at the bottom here, underneath our table, we see write a verbal expression for 5x to the third power plus 2. So by me reading it out can help us to identify the verbal expression. So this is 5 times x to the third power, or x cubed, plus 2. So saying it out loud can help you put it into words. Check your understanding. Which verbal expression represents the one shown there? Pause the video now and choose from the following choices. Check your answer. So we have 2/5. There's a hidden multiplication here, times m to the second power, or m squared. So we have 2/5, that's good, times, fine, the product of m and 2. Their product means multiplication, not what we're doing. All right, the quotient of 2 and 5. So that's also saying 2/5, quotient of 2 and 5, times the product of m and 2. We just decided that's not good. 2/5 of m squared, or 2/5 times m cubed. Well, here we have our m squared. If you see the word of, it wasn't listed as one of our things, so we should go back and put it. If we see the word of by itself, it's probably going to mean multiplication. So 2/5 of m squared, we have our 2/5 times m squared. C is our correct answer. Example 2, write a verbal expression with grouping symbols. So write a verbal expression for the one listed here. For this one, they broke it down for us and kind of wrote underneath already. So we started with a to the fourth power. That's what they wrote out here. And then our addition symbol, plus. And then here we have a fraction, so they wrote the quotient. Fractions are just division, so 6 times b and 7. If we follow order of operations, we need to be careful because we listed earlier the word and. That doesn't mean 6 times b plus 7 because that was already listed. So if we're writing it all out, they just smushed it together. A to the 4th power plus the quotient of 6 times b and 7. Personally, I like their alternate method rather than using the quotient of. So if we look at their alternate method, we still have the same part, a to the 4th power. We still have plus, but this fraction over here is what's different. Here they're saying 6 times b divided by 7. To me, this bottom one makes more sense in terms of order of operations. So this is how I would write it. A to the 4th power plus 6 times b divided by 7. And then if we're going through and evaluating, we would just follow order of operations. Example 3. Write an algebraic expression. So write an algebraic expression for each verbal expression. A says 2 times the quantity y plus 11. The word times implies multiplication. The words the quantity implies the parentheses. And plus implies addition. So writing this out, we would say 2 and then parentheses y plus 11. So here's our first instance of seeing parentheses. When you see the quantity, then know the next part is probably inside parentheses. Part B, n cubed increased by 5. So the word cubed implies a power of 3, and increased by means addition. So we could write it n to the 3rd power, or n cubed plus 5. Check your understanding using the wording to write an algebraic expression. Read through the verbal phrase, write out what each word implies, and then finally write an algebraic expression. Pause the video now and complete this check. Check your answers. First, increased by implies addition. Product of implies multiplication. So if we're putting things together, we have 18 adding the product of 3 and d. So 18 plus 3d. Example 4. Write an expression. Our real context here is soccer. In the group play stage of the FIFA World Cup, teams are placed in groups of 4, and they play each other. A team is awarded 3 points for a win, 1 point for a tie, and no points for a loss. Write an algebraic expression that represents the number of points accumulated by one team in the group play stage of the World Cup. So first, for this, let's define our variables for the unknowns. So we'll say W is the number of wins. Makes sense, they start with the same letter. T can be ties, and then Z can be the number of losses. I avoid using L, as if I write it, sometimes it looks like a 1, and I don't want to confuse myself. So we're going to use Z. So the number of points we award for wins is 3. The number of points awarded for ties is 1. And the number of points for losses is 0. So if we're thinking about in terms of our variables, we're going to add the wins, the ties, and the losses together. Continuing on here, so part A, write a verbal expression for the number of points accumulated and interpret the meaning of the variables in the context of the problem. So for this one, we're going to take our W's, our T's, and our Z's, and we need to add them together. However, we need to put the value of each in front. So the wins were worth 3 points. So we would put it as 3W. The ties are worth 1 point. So we would say 1 for a tie. And then 0 points for Z for the losses. Part B, what units are associated with the variables, the coefficients, and the expressions? That's telling the points. 3 points for a win, 1 point for a tie, 0 points for a loss. And then finally, how would the expression change if a point were deducted for each loss? Well, instead of having that 0 for Z, we would have to change it to -1Z. That's showing that each loss, or Z, loses 1 point. So it'd still be 3 for the wins, 1 for the tie, but now -1 for the Z. Check your understanding of writing an algebraic expression. Read through the situation. Write your expression for the total ticket sales if N 1-day passes and T 3-day passes are sold. Pause the video now and complete the check. Check your answers. You should have got 100 N plus 250 T. So N is the 1-day passes, and the 1-day passes cost $100, so it's 100 N. And then the 3-day passes are 250, so 250 T. If you're finding total ticket sales, you would add those two things together. Let's learn evaluating algebraic expressions. Algebraic expressions can be evaluated for given values of the variables. The substitution property also allows us to evaluate an algebraic expression by replacing the variables with their values. So our key concept here, substitution property, all that means is a quantity may be substituted in for its equal. Okay, same with substituting in sports. If your goalie gets subbed out, you're not going to put in another forward, you're going to put a goalie back in. So the same thing works here in math. You take something and you plug in what it's equal to in for that place. If M was 11 and you started with 4M, you could plug in 11 instead of M, so it would be 4 times 11. You're just putting the value in for the variable. On the side of your workbook, there's a small section that says think about it. Pause the video here and practice substituting for the quantities given. The answers will be shown in just a minute. Check your answers. If we plug in 6 for P, so instead of P we plug in 6, then it would be 3 times P, or 3 times 6, which is 18. If we use Q, which was 0.5, 0.5 to the second power is 0.25. If we plug in Q and R for their respective places, we end up with 12. And if we plug in P and R, 6 and 10, then we evaluate that, we would get 6,000. Again, notice we're just taking the value that's here and plugging it in the same place. So Q and R, their values are plugged in. Example 5. Evaluate an algebraic expression. After applying the substitution property to an algebraic expression, you can find the value of the numerical expression by using order of operations, which we learned in lesson 1. So evaluate a to the second power times the quantity 3b minus a plus 5 divided by c if a equals 2, b equals 6, and c equals 4. So for this, we're going to go through and substitute in each value where the variables were. So I'm going to start with a. Anytime there was an a, I'm going to plug in the number 2. So out front, it's now 2 to the second power. In the middle there, between the minus and the plus 5, there was an a, so that's now 2. Now I'm going to do the same for the b's. So B was 6. And finally, C is 4, so that's going to go at the end. Now we just have a numerical expression, so we can go through using order of operations. So order of operations, we're doing parentheses first, and then within the parentheses, we have multiplication, subtraction, and addition. So multiplication is going to come first. 3 times 6 is 18. Now, still order of operations, subtraction's got to come before addition because we're going left to right. 18 minus 2 is 16, plus 5 is 21. Next, we have our exponent. So 2 to the second power is going to be 4. Then, following order of operations, this is 4 times 21 divided by 4. Multiply and division are the same step, left to right. 4 times 21 is 84, and then 84 divided by 4, we're back to 21. So substituting in our values for A, B, and C, we end up with 21. Check your understanding of substituting in values and evaluating. Pause the video and complete the check. Check your answer. You should have got 3 over 8. If you got 6 over 16, 6/16, then you substituted your numbers in correctly and evaluated correctly. But remember, when our answers are fractions, you want to reduce it to lowest terms. If you changed it into a decimal, then your decimal would be 0.375. Example 6. Write and evaluate an algebraic expression. Our real context here is world records. In 2004, Chad Fell set the record for the largest bubblegum bubble blown. Assume that the bubble was spherical. The surface area of a sphere is 4 times pi multiplied by the radius squared. Part A, complete the table to write an expression that represents the surface area of a sphere. So in words, they told us was 4 times pi multiplied by radius squared. So if we're defining our variable, r is going to be our radius. So we don't know what the radius is. So our expression then is going to be 4 times pi times r squared, or simply just 4 pi r squared. Now we can use that to figure out how large this bubble was. So the record-setting bubble had a radius of 25.4 centimeters. Find the surface area of the bubble. So we know the area was 4 times pi times r squared. It tells us the radius was 25.4. So r equals 25.4. We defined r is our radius. So let's plug in 25.4 instead of r. Now, following order of operations, there's nothing really to simplify inside the parentheses, so let's move on to exponents. Using a calculator, 25.4 times 25.4 is 645.16. Now, multiplying that out by 4, we would get 2,580.64. Then multiplying it by pi, now we're saying that it's about 8,107.32. Notice the change in the symbol here. Because we're rounding off with pi, because pi goes on forever and never ends, then we're going to round off. We can change to that little symbol, and that symbol just means about. So it's about 8,107. So our final answer, the surface area of the bubble was approximately 8,107.32 centimeters squared. Check your understanding of writing and evaluating algebraic expressions. Read through the situation. First, write an expression for the attendees at those games. Then find the maximum attendees for those teams after 6 weeks. Pause the video now and complete the check. Check your answers. First, we would put 82,500 in front of J, since J is for Jets, and the Jets are at 82,500. Then we would put, if D for Dolphins, so the Dolphins are here, 65,326. And then finally, Patriots are 66,829. So this is showing that we're going to take the number of seats, multiply it by the number of home games for each of the teams, and then we can add them all together. Now, taking our same expression and evaluating, the Jets played 4 home games, so we can plug in 4 for J. Dolphins played 3 home games, so we can plug in 3 for D. The Patriots played 2 home games, so 2 for P. Multiply them out. Finally, if we're combining it all together, the total attendance for those 3 teams would be 659,636. Now, take time to pause and reflect. In the box provided, write down anything that you may have struggled with in this lesson. Did you get any of the checks wrong? If you came across any of these things, write down how you dealt with it. If you have any questions that you may need further clarification on, this would be a good place to write those as well. Pause the video now and think about how you went through it.